Hi, welcome to this video where we discuss about standard definitions of the sine wave fundamentals. So to take up the fundamentals of sinusoidal wave and the standard definitions, we need to look for definitions of RMS and value of maximum value. Before this, let us proceed with the simple definitions. Okay, so for any given waveform, sinusoidal wave, let us consider this is the sinusoidal wave. You can take the sinusoidal quantity can be either voltage or current. Okay, it can be either voltage or current with respect to time. So consider any voltage or current alternating quantity with respect to time. So how do we define certain standards of definitions? The first one, instantaneous value. First one, instantaneous values. So it is defined as the quantity at a particular instant is known as the instantaneous value. If you take the voltage or current, so any value at any instant of time. So if you call this is the instant of time, so the quantity is varying. Correct. So it can be voltage or current. You can say this can be I1, this can be I2, or it can be V2 or V1. Okay. So any point of instant of time, you measure the quantity that is called as an instantaneous values. Okay. So then now waveform. How do you define the waveform? So how do you define the waveform? The graph of instantaneous values of an alternating quantity plotted against time is called its waveform. So I can plot voltage against its time, okay, or current against its time. So this is called the waveform. The graph of instantaneous values of an alternating quantity. So V and I are called alternating quantity here. So when we plot these quantities with respect to time, that is called as waveform. The third definition is for cycle. The third definition is for cycle. So how do you define the cycle? One complete set of positive and negative instantaneous values of an alternating quantity is called a cycle. So one complete set of positive and negative. If you look at this waveform, this is the positive side and this is the negative side. The complete set from here till here, this point is called cycle. That is called one cycle. Okay. Next, fourth definition is maximum value. So it can be called as peak value. The other name used here, peak value, and amplitude. We call this the same name, refers same. That is maximum value, peak value, or amplitude. So how do you define this? The maximum value means either positive maximum value you can take or negative maximum value you can take. So in other words, I will put it in other way. I light this in a different color. So maximum value is this peak. So it can be negative peak or the positive peak. So obtained by an alternating quantity. So the positive or negative peak value obtained by an alternating quantity is called maximum or peak value or amplitude. Next, the fifth point now is time period. So let us see the fifth definition. What is time period? Fifth is time period. So how do you define time period? Is denoted as t. So it is the duration of time required for the alternating quantity to complete one cycle. So this is called T. So to complete one cycle, the time taken by an alternating quantity is called time period. Now on the same grounds, we can also define the frequency. So the frequency is the number of cycles completed by an alternating quantity per second. The number of cycles completed by an alternating quantity per second is known as its frequency, where T is given as 1 by F, or F is equal to 1 by T. So it is number of cycles completed per second. So frequency, the unit is in hertz. So next is angular frequency. The next definition we have, seventh one, angular frequency. Angular frequency, normally we denote angular frequency as omega. So this is oftenly used in single phase and three phase. Not only here, in many electrical concepts we go with this angular frequency. So the value of a sine function repeat after every 2 pi radians, okay, we call that as angular frequency. It is denoted as equal to the number of radians covered in 1 second. So omega can be given as 2 pi f, where f is a frequency. Or omega can be also be written as, in terms of time period, omega is equal to 2 pi by t, because we know f is equal to 1 by t radian per second. Now what is phase? Phase is the function of time period or cycle that has elapsed since it last passed from the chosen zero position or origin. So you can choose here. So from here to here. So this is starting the phase of this particular waveform, from origin, or it can shift towards positive or negative. That we'll be discussing in the next videos. So before moving on to the actual concepts of single phase, let us now look over what is an average value. So an average value. So I have a slide here. You can look at here. Average value and its demonstration. So average value is just taking the average of positive or negative cycle of a sinusoidal quantity. Let us derive that in a better way. Average value. Okay, so the average value of a alternating quantity is defined as that value which is obtained by averaging all the instantaneous values over a period of half cycle. So as I said, either take positive, averaging all the values, okay, at any instant, okay, taking I1, I2, I2, whatever, V1 or I1. So averaging all the values obtained after averaging is known as instantaneous value. So you can take either positive cycle, half cycle, or negative half cycle. So consider, now let us derive this. For that, consider one small portions to take the average of the positive cycle. So let us take one small portion of the sine wave. So to derive this average value, so this is small portion. Let us take this small portion. So this is a theta, d theta portion of this, and this distance is theta. Okay, that's distance. So let us take this as a current wave. So now this is a small portion of I. So now considering this elemental interval at instant d theta as shown here in the figure, the average value of a symmetric periodic waveform, because the positive is symmetric with the negative here, okay. So the average value of the symmetric periodic waveform to be determined for only half cycle. Either we have to take it for positive or negative, because later on it is symmetric, correct? Again it goes to positive, again it goes to negative. So if you consider only one positive cycle or negative cycle, that is sufficient to calculate the average value. So I average is given as area under curve for half cycle divided by length of base over half cycle. So area under curve for half cycle. So if you take this area under this curve, so if I integrate, from 0 to this value, so if you say this is 0, this is pi. If I integrate between 0 to pi, I will get the area under curve over half cycle. So this can be written as integral 0 to pi, okay, I into d theta divided by length of the base over half cycle. If you look at this, the length of the base is again pi. So this is pi. So after integrating this, you can take out 1 by pi outside, integral 0 to pi I into d theta. Now integrate this I with respect to d theta. Okay, but before that, let us substitute for this I. So we know for any for any waveform, alternating quantity I is equal to Im sine omega t or sine theta. We can say instead of omega t, we can say it as sine theta. So when you substitute I is equal to Im sine theta for this, so we can proceed with the average value equation. So now proceed with that. So as I said, it is 1 by pi 0 to pi I into d theta. Now substitute for this, that is I is equal to Im sine theta. 0 to pi I is equal to Im sine theta into d theta. Now integrate this with respect to d theta. So what we get here, so this is Im is a maximum value which is constant. We have only one maximum value over a period of half period or negative positive or negative half period. So Im divided by pi integral of 0 to pi, so sine theta into d theta. So when you integrate this sine theta with respect to d theta, this is equal to Im by pi, okay, minus cos theta integration between 0 to pi. So this is equal to Im by pi. Now apply the limits on the, for this value cos theta. So minus cos pi, minus into minus is plus cos 0. When you apply the limits, this is equal to Im by pi into 2. So I average is equal to 2 Im by pi. So this is the value. It is also given as 0.637 Im. So this we will be using in entire electrical, what is the average value. You need to find the maximum value if you know. And multiply with 0.637, you get the average value over a half positive cycle. What is the importance of this average value? So average value is used for many applications. Like why we need, basically average value, because many applications like battery charging, they take up the average values. So the charge transferred in capacitor circuit is measured using average values, and the average values is indicated by DC ammeters and voltmeters easily. The average value of purely sinusoidal waveform is always 0. Okay, so it plays important role in analysis of the rectifier circuit. So these are the advantages of the average value. So in the next slide, we'll see what is RMS value or effective value. So now RMS value or effective value. See, as the name indicates, it is root mean square value. Root mean square value. So that means you need to take a square of the alternating quantity and derive the equation for the RMS value. So let us take any current. So any current, if I square it, I would get this one as like this. So if I square it, so it goes. So you don't get any negative cycle when you square the current, because square of negative is again positive. So keeping that in mind, okay. So now let us derive. So the effective value of an AC circuit current is defined as the basis of the heating effect. So that is the steady state current of, that is DC steady state current which I'm talking, which when flowing through a given circuit for a given time produces the same amount of heat as produced by the alternating quantity, or a current which when flowing through the same circuit for the same time. So now considering the sinusoidal, as I said, this is I and I square. So this is I square and this is I. So when I take a small elementary portion again, that is d theta, okay, and this is pi, 0 to pi, and this is 2 pi, and this is with respect to time. So again, considering this equation, so the RMS value, to derive RMS value, first we need to know RMS value is equal to IRMS is equal to square root of mean or average, mean or average of square current. Okay, square current. That means I need mean or average of square current. So I have already a square current. If I find the average value of square current, we can substitute here and we can find the answer. So for that, let us take, as I said, observe this. If I find the mean or average of square current, I would get the IRMS value. So first let us find the mean or average of square current. So we know average value is given as area of curve, as I defined earlier, area of curve over half cycle divided by length of base over half cycle. So on the same grounds, I need to take 1 by pi outside, 0 to pi. I need to integrate Im square sine square theta, because instead of I need to have I square sine square theta. So in other terms, this can be written as 0 to pi I square d theta divided by pi. Correct. So if I take pi common outside, so I is substituted with Im square sine square theta into d theta. So when you integrate this is equal to Im square, you can take out common, Im square by pi integral 0 to pi, okay, 1 minus cos 2 theta divided by 2 into d theta. So when you integrate this, need to consider Im square by pi 2 pi. So theta minus sine 2 theta divided by 2. Now I'm including 1 is nothing but theta. Cos 2 theta integration is sine 2 theta by 2, and the limits you need to apply 0 to pi. So when you substitute now the limit, you will get the value as Im square by 2. Now we need to substitute this in this equation. Im square by 2 is the average value. So this is equal to root of, so when you substitute, this is Im square by 2. So when you take a root, it is Im by root 2, that is equal to 0.707 Im. So this is how we derive the equation for RMS value. Thank you for watching this video. So thank you for watching this video.